We continue NCRT exercise of the chapter Laws of Motion. And in the previous video, we have solved question number 5.9. Let us see question number 5.10. Question number 5.10. We have given that a body of mass 0.40 kg. There is a body of mass 0.40 kg. Mass of the body is 0.4 kg. Moving initially with a constant speed of 10 meter per second to the north is subjected to the north. The body is moving in a north direction. The body is moving in a north direction. And north is subjected to a constant force of 8 Newton directed towards the south. The force is acting on the body directed towards the south, and body is moving with a speed of 10 meter per second to the north. Means force is applied on the body in a direction opposite to the motion of the body. The force is applied on a body in a direction opposite to the motion of the body. The body is moving in north direction and the force is applied towards the south direction. So if the direction of force, let the direction of force, that is south direction, is considered as positive axis. Let the direction of force that is south direction we have given. The direction of force that is south is taken as positive axis. Is taken as positive axis. Means the force which is acting from south to north. So we have taken the direction from south to north. From south to north as the positive axis. Then from north to south will become the negative. And we have given that the body is moving. The body is moving with a speed of 10 meter per second to the north. Means initial velocity u is taken as negative, minus 10 meter per second. Because the force applied from south to north direction, and we have taken this direction of the force as positive, and since the body is moving, since the body is since the body is moving from north to south, therefore the north to south will be negative. If the direction from south to north through which the force is acting is taken positive, which we have supposed that the body is moving in negative axis, that is u equals to minus 10 meter per second, and the force applied is 8 Newton. F is 8 Newton, which acts from south to north. So, 30 seconds, and the force acting for the time t equals to 30 seconds. This force is acting for time t equals to 30 seconds. Take the instant the force is applied to be t equals to 0. The position of the body x equals to 0. When the force is applied means at t equals to 0. The position of the body was x equals to 0. The position of the body when the force applied, then at time t equals to 0, initial time, the position of the body x equals to 0 and predict its position at t equals to minus 5 seconds. Predict the position of the body. Predict the position at t equals to minus 5 second, 25 second and 100 second. 25 second and 100 second. In all these times, we have to predict the position of the particle. So in the very beginning, we calculate the acceleration acting on the body. And the formula for acceleration is A equals to F by m. Acceleration acting on the body, A equals to F by m. Force is 8 and mass is 0.4. So this becomes 20 meter per second square. This is the acceleration acting on the body, and the direction of acceleration is towards the south. The direction of acceleration is towards the south. Now velocity of the body v after 30 seconds. We calculate the velocity of the body v after 30 seconds. So velocity of the body v after 30 seconds. Velocity of the body after 30 seconds, and we use the formula v equals to u plus at. Initial velocity u minus 10, acceleration is 20 and time is 30. So minus 10 plus 600, and that is 590 meter per second. This is the velocity, final velocity. Velocity at time, after time, 30 seconds, 590 meter per second. And in the question we have given that when the force is applied, then at that time, initial time t equals to 0 and position x equals to 0. Now the first part which we have to calculate, we have to find the position of the particle at time t equals to minus 5 seconds. Position of the particle at time t equals to minus 5 seconds. Predict the position at t equals to minus 5 seconds. So we calculate that at t equals to minus 5 seconds, at t equals to minus 5 seconds, what is the force acting on the particle? At t equals to minus 5 seconds, what is the force acting on the body? So at t equals to the first part, at t equals to minus 5 seconds. So at t equals to 0, the body is at rest. At time t equals to 0, the body is rest. So at time t equals to minus 5 seconds, the body will also be in rest. At t equals to 0, since we have given that at time t equals to 0, the body is at rest. So time t is minus 5 seconds, which is less than 0. So at time t equals to minus 5 seconds, there is no force acting on the body because body is in rest. So at t equals to minus 5 seconds, there is no any force. acts on a body. Because the force acting on a body which has been started from time t equals to 0. So before time t equals to 0, there is no force acting on a body, and if there is no any force acts on a body, it means acceleration is 0. A equals to 0. Now we have to find the position, so we use the formula S equals to ut plus half at square. S equals to ut plus half at square. U is the initial velocity which we have given -10, time is -5, and half acceleration is 0. So this whole expression becomes 0, and the distance, the position of the particle is 50 meter. So at time t equals to -5 seconds, the position of the particle is at 50 meter. S equals to 50 meter. And at t equals to -5 seconds, there is no any force acting on the body, because the force has been started after time t equals to 0. The force acting on the body which has started after time t equals to 0. So before time t equals to 0, there was no any force acts on the body, and therefore the acceleration a was 0. Now the next part which we have to calculate at time t equals to 25 seconds. At time t equals to 25 seconds. So at time t equals to 25 seconds. At time t equals to 25 seconds, there is force acting on the body, because we have given that from time 0 to 30 seconds. From time 0 to 30 seconds, the force is acting on the body. So at t equals to 25 seconds, the second part, at t equals to 25 seconds, which lies between time 0 to 30 seconds. At time t equals to 25 seconds, there is force acting on the body. And if there is a force acting on the body, it means there must be acceleration acts on the body. So we use the formula S equals to ut plus half at square. Initial speed u is given -10, and time t is 25, plus half acceleration we have calculated 20 meter per second square, and time t is 25. So 25 the whole square. So this is -250 plus 10 into 25 the whole square, 625. So -250 plus 6250. 625 into 10, 6250, and S is equals to 6000 meter. So at time t equals to 25 seconds, the position of the body is at 6000 meter. The position of the body is at 6000 meter, and this is also written as at 6 kilometer. At 6 kilometer. Now the third part is we have to calculate the position of the particle, the position of the body, the third part, at time t equals to 100 seconds. So from time t equals to 0 to 30 seconds, from time t equals to 0 to 30 seconds, there is a force acting on the body. From time 0 to 30 seconds, the force acting on the body, but after 30 seconds, means from 30 to 100 seconds, there is no any force acting on the body. So we find the position in two parts. Firstly, we calculate the distance covered by the body from 0 to 30 seconds when the force was acting on the body. So for time 0 to 30 seconds. We calculate the distance covered by the body because in this duration there is a force acting on the body and therefore acceleration also produced. So S1 equals to ut plus half at square and u is minus 10 into 30 and plus half into 20. Acceleration is 20 which we have calculated and time square 30 the square. It goes by 10. So minus 300 plus 30 the square 900. 900 into 10 9,000. So 9,000 minus 300, 8,700 meter. This is the distance covered by the body from 0 to 30 seconds, 8,700 meter. Now, for after 30 second to 70, 30 second to 100 second, in duration from 30 to 100, which is 70 seconds, there is no force acting on the body. So for time, this is the value of S1, 8,700 meter. For time, 30 second to 100 second. And the duration between them is 70 seconds. So again we use the same formula. S equals to ut plus half at square. S equals to ut plus half at square. S equals to ut plus half at square. But our velocity gets changed because after 30 seconds, the velocity was 590 meter per second. After 30 seconds, the velocity was 590 meter per second. So at the place of u, we use 590 meter per second because the velocity has been changed after 30 seconds. So after 30 seconds, the velocity is 590 and time t is 70 and half acceleration is 0 because after 30 seconds there is no any acceleration acting on the body. So it becomes, is this whole terms becomes 0. (590) into 70. 41300. 41300 meter. So this is the distance covered S2. Distance S2 equals to 41300 meter. Means from 70 second to from 30 second to 100 second, the distance covered. Now the total distance covered. Total distance covered from 0 second to 100 second. From 0 to 100 second. S equals to S1 plus S2. So 8700 plus 41300. So 41300 plus 8700. This is 50,000 meter. 50,000 meter. And that is 5 kilometer. 5 kilometer. So the distance covered from 0 to 100 seconds is, this is 50,000 meter means 50 kilometer. The distance covered from 0 to 100 seconds is 50 kilometer. So in the question we have given that the mass is 0.4 kg and initial velocity is minus 10 meter per second. Force acting from time 0 to 30 seconds and time is 30 seconds. So we calculate the acceleration acting on the body from 0 to 30 seconds. A equals to F by m. Then we find the velocity of the body after 30 seconds. which we get 590 meter per second. And also we have given that at time t equals to 0, x equals to 0, we have to predict the position at t equals to minus 5 seconds. So at t equals to minus 5 seconds, there is no any force acting on the body because force has started acting on the body from time t equals to 0 second. So before 0 second, there is no force acting. So acceleration is 0. Now the distance covered ut plus half at square. We get the distance 50 meter at time t equals to minus 5 seconds. Now for time t equals to 25 seconds, since between 0 to 30 seconds the force acting on the body, so acceleration must be act, and we use the formula s equals to ut plus half at square. Till up to 30 seconds the speed was 10 meter minus 10 meter per second. Then for 0 to 100 second, we divide this 0 to 100 second in two parts, from 0 to 30 second and from 30 second to 100 second. Because from 0 to 30 second, the force is acting, therefore acceleration exists, and acceleration is 20. And then from 30 to 100 second, there is no any force acting on the body, and hence the acceleration is 0. Now the next question. A track starts from rest. Question number 5.11. A track starts from rest and accelerates uniformly at 2 meter per second square. A track starts from rest means initial velocity u is 0 and acceleration is 2 meter per second square. Initial velocity 0, acceleration is 2 meter per second square. At t equals to 10 seconds, a stone is dropped by a person standing on the top of the truck. At t equals to 10 seconds, a person is standing on the top of the truck and person drops a stone at time t equals to 10 seconds. On the standing on the top of the truck 6 meter high from the ground. The man is standing at a height 6 meter from the ground, means height of the truck is 6 meter. So what are the velocity and acceleration of the stone at t equals to 11 seconds? We have to calculate velocity and acceleration. Velocity and acceleration of the stone at t equals to 11 seconds. At t equals to 11 seconds, the velocity and acceleration of the stone. So firstly, we find the velocity of a stone after time t equals to 10 seconds. Velocity of a stone after time t equals to 10 seconds. After time t equals to 10 seconds. Because at time t equals to 10 seconds, a stone is dropped. And we use the formula v equals to u plus at. Initial velocity u is 0, acceleration is 2, and after 10 seconds. So velocity is 20 meter per second. So the velocity of the stone after 10 seconds is 20 meter per second. Now after falling the stone from the truck, its horizontal velocity, since truck is in moving position, so the velocity 20 meter per second. The stone, this is the horizontal velocity of the stone because truck is in moving condition. So after falling the stone from the truck, its horizontal velocity after falling the stone from the truck, the horizontal component of velocity Vx equals to 20 meter per second. The velocity which we have calculated, this is the horizontal component of velocity, and the initial velocity of a stone along y-axis. Initial velocity of a stone along y-axis. So initially the stone was at rest. So initial velocity of a stone along y-axis means uy. Uy is the initial velocity of a stone along y-axis. Since it was in rest, so ay equals to 0. Now we calculate the final velocity of a stone along the y-axis. This was the velocity of a stone along the x-axis. We find the final velocity of a stone along the y-axis. So for this, we have to calculate the acceleration along y-axis. The acceleration along y-axis. So acceleration along y-axis. Acceleration along y-axis in time interval. It was dropped from time t equals to 10 second, and at time t equals to 11 second we have to find the velocity. So acceleration of a stone along y-axis, along y-axis, that is ay, equals to acceleration due to gravity, which is 9.8 meter per second square. Along the y-axis, the acceleration acting is the acceleration due to gravity, because the stone is in contact with the gravity. Now we have to find the velocity at time t equals to 11 seconds. Velocity of a stone at time t equals to 11 seconds. So at t equals to 10 seconds, the stone is dropped, and we have to calculate the velocity at time t equals to 11 seconds. So the duration of time interval is 1 second. And this is the vertical, this is the velocity along y-axis. So Vy equals to V equals to Uy plus At. A means acceleration due to gravity, Gt. So Uy is 0, G is 9.8, and the time interval is 1. So final vertical component of velocity of the stone is 9.8 meter per second. Vy is equals to 9.8 meter per second. When the stone was dropped from the truck, so since the truck is in moving condition, so the velocity V, this was the horizontal component of velocity. V equals to U plus At. We use the acceleration of the truck 2 meter per second square. So this was the horizontal component of velocity, horizontal component of final velocity. Then we calculate the acceleration along the y-axis. So since the body is in contact with the gravity, so acceleration is equals to G 9.8 meter per second square. Now at time t equals to 10 seconds, the stone is dropped, and we have to find the velocity at time t equals to 11 seconds. So the time duration is 1 second. So in 1 second, the final velocity acquired by the stone in y-axis is Vy, which is equals to 9.8 meter per second. Now we find the resultant velocity. So resultant velocity is calculated by using the formula V equals to under root of Vx square plus Vy square, and Vx is 20 the whole square plus Vy is 9.8 the whole square, and after solving we get 22.3 meter per second. So the velocity of the resultant velocity of the stone at time t equals to 11 seconds is 22.3 meter per second. And if the resultant velocity makes an angle of theta with the horizontal component of velocity, if the resultant velocity if the resultant velocity makes an angle theta with the horizontal component of velocity, then tan theta, this is the case like this is the horizontal component of velocity Vx, this is vertical component of velocity Vy, and this is the resultant, and we have supposed that the resultant V is making an angle theta with the horizontal. So tan theta, if this is Vy, then this will also be Vy, and this is Vx, so tan theta equals to Vy upon Vx. And the value of Vy we have calculated 9.8 and Vx is 20. So tan theta equals to 9.8 upon 20, which is around 26 degree 12 minutes. And theta equals to tan inverse 9.8 upon 20, which is 26 degree and 12 minutes. So this is the angle which the resultant makes with the horizontal. Now we have to find the acceleration. So horizontal acceleration in this case is 0, and the vertical acceleration acting is the acceleration due to gravity. Horizontal acceleration is 0, and the vertical acceleration is the acceleration due to gravity, which is 9.8 meter per second square.